Good afternoon, everyone. I want to do a quick video here to talk about the idea and differences between control flows and object flows. So what you're looking at here in this diagram is there are a few different loops, and these loops contain both control flows and object flows. So a SysML control flow looks like this. It's the dashed line, whereas an object flow is a solid line. However, they are used very differently in your models, and especially within simulations and things of that nature. One of the big mistakes that I see people making is they will use both object flows and control flows together. So what you'll end up seeing is you might have this object flow here, but then someone will also add a control flow simply to show that they'd like this to go from here and then to here. And in most cases, that is completely unnecessary. Now, in this case, it's not going to cause any issues. However, if you're adding more elements to your model than you need, that's typically a bad thing, and it's going to clutter things up. And I've seen some diagrams where things just look very, very messy because you're having to put control flows all over the place and things like that when you really don't need them there. So in this case, what you'll see happen is we'll run this with context in order to access some of the value properties of the block that executes this activity. So these are the value properties that we'll be looking at: the current temperature and the desired temperature. Notice there's a default value currently for desired temperature of 17 degrees Celsius. And what will happen is, slow this down a little bit, this accept event action is waiting for that trigger, which is the signal. So we can send that by selecting that signal here. And what you'll notice is that object of the value property will send its runtime value of 22, which is the default value that we had. That's the default value for the signal attribute that I had set. So if you look up here, what you'll notice is there is a default value for that set to 22. And then that gets passed to this store desired temperature action and assigned to the runtime value of desired temperature. So that works very well. Then we can evaluate those runtime values with guards such as these, where we see current temperature greater than desired temperature going to this path, and conversely the opposite over here, or if they're the same, we would take this path. So that is a very simple way to do that. And as I mentioned, you really do not need additional control flows. And if you had that, it would not cause any issues, but it's cluttering up your model, and you're adding things in that you really don't need to be there. So what you'll see is, in this case, the control flow is sent first, and then that object flow follows that. So typically, in order to enable an action, what has to happen is there has to be a token on all of the incoming edges. So this is an edge. This is also an edge. An edge in SysML is what we typically think of as control flows or object flows. So a token was traversed this control flow. It enabled this. And then what happened was that object was then delivered. So specifically with things such as object flows, if you did not have that control flow, you can still inhibit this action from becoming enabled depending on how you set the multiplicity of that input pin. So if I were to say that this does not require any inputs, you can actually go into the specification for this, look at that multiplicity and say either 0 or 0 to 1. So that's not requiring an input, but at most it could have one input, or you could say that it needs to have absolutely one. But if you do not specify that, then when you run this simulation, that simply defaults to a multiplicity of 1, which means it requires an input at that pin in order for this to become enabled. So that is a way you can manage how things become enabled without a control flow as well, if you simply want to use the input pins to do that. I'd also like to go over to another quick example here with an acceleration model. And what you'll see in this is we only want to calculate our vehicle velocity after a certain amount of time has passed. And that's based on the change in time value that we're looking at, which in this model specifically is 100 milliseconds or 0.1 second. So there's a default value set to this delta t value, this dt, that this model grabs in runtime. And if you look at the block definition diagram for this, what you'll see is that is right here. So dt is set to 0.1, and that's 0.1 seconds. So going back to this, what will happen is when this becomes enabled through the token arriving, what you'll see is the vehicle velocity will add the acceleration, multiply that by that 0.1 seconds, and then that will be ready to deliver that value to this next property, which is the updated vehicle velocity. But we only want to do that after 100 milliseconds. So this really goes into that idea of control flows being used to inhibit an action from becoming enabled until we want them to become enabled. And in this case, we're saying that we want it to wait that specific amount of time, then become enabled, then do this calculation where we actually assign this value that's the velocity final, which was this calculation, to the new updated vehicle velocity. And then that will loop around and continue to do that. So that is a very important concept. I could go ahead and run this, and what you'll see is if we slow this down, you'll see that happen. So notice this control happens first, it's waiting, and then that value of 2.8 was delivered. Could slow that down even more. And then you'll notice there is a wait there. It's only 100 milliseconds, so not very long. But then after that amount of time has elapsed, then that value is allowed to come into this action, enable that, and then we are assigning that value. So really important concept to understand when doing SysML modeling is that difference between when you'd like to use a control flow or when you would only like to use an object flow. Sometimes you need to use them together. Sometimes you only need object flows. But that's a great concept and something to definitely have a good handle on when you start doing activity diagrams especially. So if you have any questions on that, feel free to reach out. Thanks a lot.